This is on the problem for electromagnetic waves and wave optics. In Young's double slit experiment, two coherent sources of intensity ratio of 64:1 produces an interference fringes. Calculate the ratio of maximum and minimum intensities. So I1 and I2 is equal to 64:1. So I max by I min needs to calculate. The solution is I1 divided by I2 is equal to A1 square divided by A2 square. So I1 divided by I2 is equal to 64 divided by 1. That's A1 by A2 is equal to 8 divided by 1. You got A1 is equal to 8 into A2. I max divided by I min is equal to A1 plus A2 whole square divided by A1 minus A2 whole square. You got, replacing your A1 with 8A2 plus A2 divided by 8A2 minus A2. You got 9A2 divided by 7A2 whole square. So cancelling A2 and A2, you got 9 square divided by 7 square. That's 81 divided by 49, which is equal to 1.6531. The ratio of maximum and minimum intensities are 1.6531. Let's move on to the other example. In Young's experiment, the width of the fringes obtained with the light of wavelength 6000 angstrom is 2 mm. Calculate the fringe width if the entire apparatus is immersed in a liquid of refractive index of 1.33. So lambda is equal to 6000 angstrom, or 6 into 10 power minus 7 meter. Beta is equal to 2 mm, that's 2 into 10 power minus 3 meter. And the refractive index mu is equal to 1.33. We need to identify B dash. The solution is bandwidth of the interference of light is B dash equal to D into lambda dash divided by D, where lambda dash is equal to lambda divided by nu and beta is equal to D into lambda divided by D. You got it as B dash is equal to D into lambda divided by D into nu. So B dash is equal to B divided by nu. So putting the values of beta 2 into 10 power minus 3 divided by 1.33, you got B dash is equal to 1.5038 into 10 power minus 3 millimeter. The fringe width if the entire apparatus is B dash is equal to 1.5038 into 10 power minus 3, that's 1.5 millimeter. A soap film of refractive index 1.33 is illuminated by a white light incident at an angle of 30 degrees. The reflected light is examined by the spectroscope in which dark band correspond to the wavelength. So we got the value as mu is equal to 1.33, I is equal to 30 degree, lambda is equal to 6000 angstrom, this is the standard value, and n is equal to the smallest thickness is 1. We need to identify the value of t. Let's see. The solution is mu is equal to sin I divided by sin r. So sin r is equal to sin I divided by nu, that's sin 30 degree divided by nu, it's 0.5 divided by 1.33. We got the value as sin r is equal to 0.3759. As you know, cos r is equal to root of 1 minus sin square r. Replacing the value of sin r here, you got cos r is equal to root of 1 minus 0.3759 whole square, which is nothing but 0.14130. We got it as root of 0.8587. So cos r is equal to, the value is 0.9267. So interference due to the reflected beam is given by the formula 2 into mu t cos r is equal to n lambda, where t is equal to n lambda divided by 2 mu cos r. So the value of n is 1 and lambda is equal to 6 into 10 power minus 7 divided by 2 into 1.33 into 0.9267, which is here. We got the value of t is equal to 2.434 into 10 power minus 7. That's the value. Where t is the thickness of the ring. The reflected light is examined by spectroscope in which the dark band is almost 2.434 into 10 power minus 7 meter. A plano convex lens of radius 3 meter is placed on an optically flat glass plate and is illuminated by a monochromatic light. The radius of the 8th dark ring is 3.6 millimeter. We need to calculate the wavelength of the light used. The radius r is 3 meter, n is equal to 8, and the radius of the 8th dark ring is 3.6 millimeter. It's 3.6 into 10 power minus 3 meter. We need to identify the lambda value. The solution is Rn is equal to root of n into r into lambda. So Rn square is equal to n r lambda. Lambda is equal to Rn square divided by n into r. So it's nothing but 3.6 into 10 power minus 3 whole square divided by 8 into 3. So the answer is 2.96 into 10 power minus 6 divided by 24. The value is 0.54 into 10 power minus 6. That's the value. So lambda is equal to 54,000 into 10 power minus 10 meter. That's lambda is equal to 5,400 angstrom. So the wavelength of the light is lambda is equal to 5,400 angstrom. That's it. Thanks for watching a GTech Techno Solutions product and the problems. Thank you.